Throughout history, humans have been masters of energy. We've constantly upgraded our ways of tapping into it, propelling our progress forward. Back in the day, surviving meant eating what we could find. But once we tamed fire, everything changed. Suddenly, we could control energy, keeping warm, staying safe, and cooking our meals. We didn't stop there. We put animals to work, sailed with the wind, and even harnessed the power of flowing water. Then came steam power, kickstarting the industrial era. Nowadays, we dig up fossil fuels to light up our lives and fuel our rides. From the birth of stars to the mind-bending forces shaping galaxies, prepare to be astounded by the boundless potential of the cosmos. So, buckle up and prepare for an odyssey like no other. Join us as we embark on a voyage through the cosmos, igniting your curiosity and expanding your horizons. Don't forget to hit that subscribe button to stay updated on our cosmic adventures. Together, let's embark on a journey to the stars. All these energy sources might seem totally different, but guess what? They all have one big thing in common: the sun. Yep, that big ball of fire up there powers everything. When sunlight hits the earth, plants soak it up, turning it into chemical energy. When we eat those plants or burn them, we're basically using that solar power for ourselves, whether it's for food, warmth, or just feeling good. Even those fossil fuels we rely on so much, they're just ancient plants and critters that got buried and transformed over millions of years. And those water wheels and ship sails? Yep, you guessed it. They're also powered by the sun. Liquid water on Earth? Thank the sun for that too. It heats things up, makes water evaporate, form clouds, and then pour back down as rain. So, when water rushes downhill, it's basically solar energy in action. Same goes for wind power. Differences in air temperature and density, all thanks to the sun's heat. Not all our energy comes straight from the sun. Take Iceland's geothermal energy, for example. It comes from deep within the Earth, where forces from when the planet formed and radioactive stuff in the core do their thing. Then there's nuclear power, made by splitting atoms, and tidal energy, thanks to gravity's dance between the Earth, Sun, and Moon. But these make up just a small chunk of our energy pie, with sunlight reigning supreme for now. As our world keeps getting fancier, we're gonna need more juice. Population's booming, like nearly 10 billion of us by 2050, and we're all craving more energy for our gadgets. Think about it. Computers, tablets, phones, we're hooked on them, and they guzzle power. Plus, we keep inventing cooler stuff that sucks up even more energy. Take Fugaku, which sounds like a kind of sushi, but it's actually the world's fastest supercomputer. It uses enough energy to power 20,000 homes when pushed to its prodigious limits. Then there's the Large Hadron Collider at CERN in Switzerland, which has an annual energy consumption equivalent to that used by 300,000 homes. In the last 200 years or so, the total energy consumption of mankind has increased almost 2,500%, compared to a population increase of about 700%. And we're showing no signs of slowing this trend down anytime soon. But there's a problem. The energy available to us here on Earth is not an infinite resource, and sooner or later, we're going to start running out. Earth Overshoot Day is calculated as the date each year when humanity's resource consumption exceeds the levels the Earth is capable of regenerating the following year. It isn't an exact science, but it's a good illustration of how much we're eating into unsustainable reserves of things like fossil fuels. Think of it like a doomsday clock, but for key resources instead of the total annihilation of mankind. Back in 1987, Earth Overshoot Day hit on October 23rd. Fast forward to 2019, and bam! It's at the end of July. Translation: we're burning through energy faster than we can say, oops. Our needs keep growing, but our stash keeps shrinking. Sooner or later, we'll hit rock bottom. So, what's the game plan? Cue Freeman Dyson, circa 1960. He had a light bulb moment. Why mess with middlemen like fossil fuels or wind power? Let's go straight to the source, the sun. It's like skipping the grocery store and picking veggies from your garden. You might imagine endless rows of shiny solar panels stretching across barren deserts on Earth. But here's the scoop. Only a tiny speck of the sun's energy reaches us. Stars, like the sun, emit energy in all directions. So, even if we cover Earth in solar panels, we'd only snag a fraction of the sun's immense power. Enter Dyson. He realized that to harness the sun's full potential, we need to think big. Really big. Enter the Dyson Sphere, a mind-blowing concept to capture all of the sun's energy. Picture this, a colossal structure enveloping the sun in a gigantic shell. Now, hold up. We're venturing into that fascinating zone where science fiction meets potential reality. Sure, building this megastructure is light years away, but many scientists reckon Dyson spheres, in some form, are a logical step for advanced civilizations, maybe even inevitable. Imagine a colossal structure, like a giant shell, wrapping around a star. This isn't just any shell. It's a powerhouse, covered in solar panels, soaking up every bit of sunlight. The star, like our sun, pumps out energy at an astonishing rate, 385 yottawatts to be precise. Now, a yottawatt might sound like a word from a sci-fi novel, but let's break it down. It's 22 trillion times more power than all of humanity currently uses. Wrap your head around that. Picture this. If every star in our galaxy hosted civilizations like ours, each needing energy, one Dyson sphere around our sun could fuel them all. And get this, even if we tossed in 1 trillion more civilizations from our neighboring galaxy, Andromeda, our Dyson sphere would still have power to spare. It's like having endless energy with extra to share with the entire cosmic neighborhood. Who wouldn't want in on that? The problem is, even as far as hypothesized solar megastructures go, a Dyson sphere would be kinda tricky to build. The radius of these theoretical spheres is typically assumed to be 1 astronomical unit. That's about the distance between the Earth and the Sun, with the idea being that sunlight hitting the interior of the Dyson sphere would be of the same intensity as we're used to here on Earth, meaning we could happily live on it. But let's take a second to think about how ridiculously big this thing would be. Imagine a colossal sphere stretching 93 million miles across, wrapping snugly around the sun. It's so vast that it includes the orbits of Mercury and Venus within its grasp. This megastructure dwarfs Earth, boasting a surface area 550 million times greater. Now, let's dream a bit bigger. Picture transforming the entire interior into a habitable zone, a feat that comes with a heap of technical challenges we won't dive into right now. If we were to spread out the population, maintaining a similar density to Earth, this megasphere could house nearly 4 quadrillion people. That's a whole lot of elbow room. Can you imagine living in a megasphere floating among the stars? It's mind-blowing. But hey, we've only scratched the surface of this incredible concept. There's so much more to explore in the vast universe of space science. So, don't hit pause just yet. Keep watching, keep learning, and keep exploring with us. Hit that subscribe button and join our cosmic journey. Together, let's uncover the mysteries of the cosmos and expand our horizons. Who knows what wonders await us in the stars? Stay tuned, space enthusiasts, and let's make the impossible possible.